Welcome to today's class. In today's class, we discuss about the Monte Carlo simulation. So, in this class, a student can learn what is actually simulation, reasons for using simulation, the advantages and disadvantages of simulation, steps in the simulation process, practical applications of simulation, and Monte Carlo simulation. Now we discuss about what is actually simulation. In general, simulation is a method of solving decision-making problem by designing, constructing, and manipulating a model of the real system. It is a useful technique for solving a business problem where many values of the variables are not known or partly known in advance, and there is no easy way to find these values. Simulation is a representation of real-life situations. It is a method in which a replica of a real-world process or a system is developed over a period of time. The simulated model acts in the same manner as the selected physical or abstract process or system behaves in reality. A small example, a aircraft pilot are given training through simulation models because training with real aircraft can incur huge cost as well as involve various risks. Similarly, nowadays, many organizations like Maruti company provides the training, car driving training inside a room, and that is actually known as a simulation. Means without go to the road or you drive the car on a road, you can practice by using the simulation model inside a room. So there is no risk. Similarly, in education sector, teachers are trained in the simulated models of the students. That is, a group of individuals who imitate as students. This avoids the risk of spoiling the future of students if the teacher is not able to teach properly. Therefore, simulation models have proved to be useful for training purpose. Similarly now, simulation that is not an optimizing technique helps decision makers to perform experiment with new values of variables or parameters in order to understand the changes in the performance or effectiveness of a real system and to make better decision. Such experiments allow to answer what if questions relating to the effects of change in the value of variables or parameters on the model response. So simulation is just a mathematical tool. Now, category of simulation. Simulation used for training purpose is divided into three categories, which are live simulation, virtual simulation, constructive simulation. So what is actually the live simulation? Live simulation means actually it refers to a simulation in which equipment is used to imitate a real system. For example, testing the battery of a car with the help of an electrical tester. Similarly, virtual simulation. It refers to a simulation in which real people operate on simulated system. For example, a pilot flying a simulated jet. Constructive simulation. It refers to a simulation in which simulated people operate on simulated system. For example, in war games, the player supervise soldiers and equipment which move around the board. So this is the category of simulation. Therefore, it can be understood that simulation models are the most appropriate for uncertain situations. By using simulation, an analyst can introduce constant and variables related to a problem, develop possible courses of action, and establish measure of effectiveness. Simulation helps an analyst in determining how a system would respond under given condition. However, it does not generate optimal solution. Therefore, an analyst has to generate solution for what he or she wants to test. So, after discussion, we conclude a definition. Simulation is the process of designing a model. Simulation means what? You develop a model of a real system and conducting experiments with this model for the purpose of understanding the behavior for the operation of the system. So let us discuss with a small example. Suppose many people are booked their appointment time to meet a doctor for diagnosis their disease. But in online, at the other end, at the doctor's end, they provide a time or a token number to all the patients, to all the customers. So after understanding the experiment means the behavior of the system, how many customers, how many patients visit every day to the doctor's house, and what is the time period, total time period, or what is the waiting period for a patient in the line or in a queue, that will be experimented. In this way, after a long experimental process, the doctor provides a appropriate time and that means the schedule and the token number or the serial number for visiting. That is the meaning of a simulation. That is a model. If you are not experimenting and give a time to every patient, the patient come to the doctor's house and sitting a long period of time, and they hesitate and they feel boring. That is actually the problem faced by the patients. So that is not your simulation. Again, what is simulation? Simulation is the technical process of designing a model of a real system. And with the help of this model, we go for number of experiments and understand the system behavior, how to operate the system. That is actually the definition of the simulation. Then simulation, I am defined here, it is or it is not. Simulation is a technique which uses computer. Similarly, it is not an analytical technique which exert solution. So again, it is an approach for reproducing the process by which events of chance and change are created in a computer. It is not a programming language, but it could program into a set of commands which can perform a language to facilitate the programming simulation. It is a procedure for testing and experimenting on models to answer what if, then, so, and so types of questions. So that is actually what we can do with the help of simulation and what is not possible by using the simulation. So that's why I mentioned here it is or it is not. Then why we need simulation? That means the reason for using simulation. Simulation is a quantitative tool for business decision making process. Moreover, it is useful in situations when experimenting with a real system is risky and expensive. Suppose a person needs how to drive a jet plane. If he practice in the real system, then there is high risk and expensive. So therefore, you can use the simulated model to train a person to run a jet plane. Similarly, in case of a number of problems, we have been able to find through straightforward techniques, mathematical solutions to the situation. The economic order quantity, the simplest solution to a linear programming problem, or a branch and bound solution to an integer programming problem are some of the typical example we can cite it. However, in each of those cases, the problem was simplified by certain assumptions so that the appropriate mathematical technique would be employed. It is not difficult to think of managerial situations so complex that mathematical solution is impossible given the current state of the art in mathematics. In these cases, simulation offers a good alternative. If we insist that all managerial problems have to be solved mathematically, that we may find ourselves simplifying the situation so that it can be solved. Sacrificing realism to solve the problem can get us in real trouble. Whereas the assumptions of normality in dealing with a distribution of inventory demand may be reasonable. The assumptions of linearity in a specific linear programming environment may be totally unrealistic. Suitable for the decision maker, in other cases, they simplify or not. Simulation is an appropriate substitute for mathematical evaluation of a model in many situations. Then, simulation is applicable for solving problems in various areas, such as police dispatching, selection of location for emergency vehicle, that means ambulance or fire brigade, inventory control and financial planning. Apart from this, simulation can also be used for portfolio selection, capital budgeting, and production process scheduling. In military operation, it is used for designing weapon systems. Apart from this, we also use the simulation in various other fields such as science and technology, business decision making, and defense operations. For example, in organizations, simulation models are used to understand various business processes and take decisions accordingly. Different organizations use different types of simulation model based on their requirement. So for every organization, the simulation models are different. Basically, the simulation is required because simulation may be the only method available because it is difficult to observe the actual environment. It is not possible to develop a mathematical solution. Actual observation of a system may be too expensive. There may not be sufficient time to allow the system to operate extensively. Actual operations and observations of a system may be too disruptive. So these are the causes so that we are used simulation. Then we discuss about the application area of simulation. The various application area of simulation is simulation in the education sector, simulation in the medical sector, simulation in the entertainment sector, simulation in the manufacturing sector. So simulation, as we know, simulation is applicable for solving problems in various areas. So again, we'll discuss here simulation in the education sector, simulation in the medical sector, simulation in the entertainment sector, and simulation in the manufacturing. So first we discuss simulation in the education sector. Simulation is widely used for education purpose. Simulation models are used to create a real world environment in a classroom that helps students to understand various key concepts. In business school, these models are used for management games and to perform experimentations with different business strategies in a risk-free environment and conduct case study discussion. So, simulation is used in the educational sector in this way. Apart from this, social simulation models are used to demonstrate social and political process in various subjects such as anthropology, economics, history, political science, and sociology. For example, in, in civics simulation, students assume a behave in a simulated society. Similarly, in international relations simulation, students are engaged in negotiations, formation of alliance and cross-border trade. Simulation in the medical sector. In medical sector, simulation models are developed to teach how to diagnostic the patient, means to know the different procedures and various medical concepts. Moreover, these models are used to make decisions related to the recruitment of healthcare personnel. Simulation models are also developed for providing training on blood draw, laparoscopic surgery, and trauma care. They are also used for designing devices for biomedical engineering problems and new therapies and treatments. So in the medical sector, we use this simulation model to solve our problem. Simulation in the entertainment sector. So entertainment sector means by using computer or video games. Generally, students are playing the video games with the computer, but that is designed by using the simulation model. It refers to simulation games that represent a real environment. These games represent interactions between playable character and environmental realistics. Nowadays, simulation games are popular among people of all our groups. Some of the players of popular simulation games are, what are the popular games? World of Tanks, War Thunder, World of Warship, Train Sim World, etc. Then Film. Film is also one part of the entertainment sector. It refers to one of the most important application of simulation. In the field of entertainment, simulation models are used to provide 3D computer graphics and special visual effects in films. In this way, these models are used for producing high quality film and controlling visual effect. Some of the film in which simulated models have been used are Finding Wally, Life Free, Die Hard, Iron Man, like that. So in this way, simulation is useful in entertainment sector. Simulation in manufacturing. So as you know that manufacturing means to produce the product, to develop the finished product. The field of manufacturing has a wide application of simulation models. These models are used for evaluating the effect of capital investment in equipment, plants, warehouse, and distribution centers. Simulation models can also be used to determine the performance of the existing and planned system. The following are some main application of simulation model in manufacturing. Let us discuss determine the throughput under average and peak loads, calculating system cycle time, making efficient utilization of resources such as main, raw material, money, machine, etc. Identifying bottlenecks and shortcomings in the production process, solving the problems of queuing in a work environment, identifying staffing requirements, determining the effectiveness of scheduling and control system. So this is not a different application area of simulation. Simulation in the education sector, simulation in the medical sector, simulation in the entertainment sector, simulation in the manufacturing sector. Then we discuss about types of simulation. How many types of simulations are there? As we know, simulation models are used when a real system is not accessible, can be dangerous to engage, or has not been built. As discussed earlier, these models are used in various fields such as safety engineering, testing, training, and education. Simulation model can be classified on the basis of changes produced in a system and uncertainty in the processes, events, and controlling parameters of the system. The two classifications of simulation model are mentioned below. The first classification is on the basis of the changes produced in a system. This classification includes the following. Static simulation. It refers to a simulation in which a system does not show any change with time. Static simulation represents a system at a particular point in time. Similarly, dynamic simulation, it refers to a simulation in which a system changes and evolves with time. The main objective of dynamic situations or simulation is to estimate the future performance of a system. Here, I am explaining on the basis of the change produced in a system. Here I am explaining on the basis of uncertainty in the processes, events, and controlling parameters of a system. This classification includes the following: deterministics and probabilistics. What is actually deterministic simulators? or simulation? It refers to a simulation in which the parameters are uncertain and are expressed by using a single value. The result of deterministic simulation is in the form of a qualified statement. Then, probabilistic simulation. It refers to a simulation in which uncertain are defined very clearly by specifying inputs as probability distribution. The result of probabilistic simulations are a quantified statements. Then the steps involved in the process of simulations are explained as below. Identifying a problem. The first is identify the problem, how to solve the simulation process. The second one is developing a model. And the third one is collecting data. And the fourth one is running the simulation model. Then fifth is interpreting the results. Then identifying a problem refers to the first step of the simulation process in which problem is clearly defined. All the problems are clearly defined and intended solutions to be achieved are identified. If the problem is defined clearly, it will lead to the development of an appropriate model and provide a basic for the evaluation of simulation result. Developing model. The second criteria, developing a model. It involves formulating a model by considering the problem that is identified in the first step. A simulation model can be a physical or mathematical model, idea or combination. Then the third one is collecting data. So after identifying problem, developing a model, and the third one is collecting data. It involves gathering data for the development and evaluation of the simulation model. The collected data helps in analyzing the problem and reaching at an appropriate solution. Running the simulation model refers to one of the most important steps of the simulation process. After developing the simulation model and collecting the relevant data, the next step is to turn it. If the model is deterministic, a single run would be sufficient. On the contrary, if the model is consider different parameters, that is known as random numbers, a number of runs would be required to evaluate the performance of the model. That means statistics. Interpreting the results involves analyzing the results of the runs. If the model portrays a real life situations, no rectifications will be required. However, if the model is not closer to reality, a number of runs will be required. So, these are the steps involved in the process of simulations. I have explained here: identifying a problem, developing a model, collecting a data, running the simulation model, and the fourth one is interpreting the result, the final result. Then we discuss about the important means advantages and limitation means disadvantages of simulation. Simulation is a useful technique, specifically in situations where mathematical simplifications is not possible. The following are some of the advantages of simulation. Simulation helps an analyst in observing and studying a real-world environment or process that cannot be studied in its actual form due to some reasons, such as high cost and greater risk. Another approach also we discuss here, it enables an analyst to study process that are long-term and require more time to display results. For example, for studying trends in the world population in the long run, an analyst cannot wait for the required number of years to see the result. Helps in studying the system that are too disrupting in nature. However, in case of complex business problem, a simulation may suffer from various limitations. Some of the limitations of the simulations are time consuming, expensive, no optimum results, complicated process. However, we discuss here time consuming. It refers to one of the major drawbacks of simulation. In certain analytical process or simulation has proved to be time consuming. Expensive. It implies that a better and more advanced simulation model would be more expensive. Simulation often require significant use of computer, which increases the cost of electricity. This incurs high cost to organization. No optimum results. It refers to another major drawback of simulation, since a simulation model generally deals with uncertainties. Optimum results cannot be produced. A simulation model can prove or provide a way of evaluating solutions but does not generate any solutions. Complicated process. Simulation involves a long and complicated process to develop a model. Such a model is unique and developed for obtaining the solution of a specific problem. Then we discuss about Monte Carlo simulations using random numbers. Monte Carlo simulation is a problem-solving technique that is used to represent the probability of certain outcomes by running a number of trial runs, experiments. Trial run means number of experiments. We get one output. That is called as simulations and using random variables. This technique was introduced by John von Neumann while they are working on the atomic bomb in the 1940s. These scientists named this technique after the city in Monaco, which is famous for casinos and games of chance. The steps involved in the Monte Carlo simulation techniques are explained as making probability distributions for variables, building a cumulative probability distribution for each variable, generating random numbers, and the fourth one is simulating the experiment through random sampling. So making probability distribution for variables. That means this step, this is the first step, this step involves estimating a probability distribution for the given variable based on the past experiments. So on the past data, on the basis of past data, we have to find the probability. We have to estimate the probability distributions. The distribution can be based on Poisson, binomial, or normal distributions. Then what is the second step? Building a cumulative probability distribution for each variable. So after getting the probability distribution, we have to find the cumulative probability distribution. Then we generate random numbers. What is actually the random number? A random number is a series of 2 digits or 3 digits numbers. For example, 0001 up to 99. That is a 2 digits numbers. So these are the random numbers we can consider. A random number can be generated in many ways. For example, if a problem is very complex and involves a number of simulation trials, random numbers can be generated using computers. Then what is the next step? Simulating the experiment through random sampling. It involves repeating the process till the required number of simulation runs has been generated. Then various application area of Monte Carlo techniques. So it can be applicable in physical science. It is applicable in finance. It is applicable in telecommunication. It is also applicable in games. First, we discuss here physical science. It is a field in which the Monte Carlo technique has proved to be very effective. The Monte Carlo technique is used in computational physics, physical chemistry, and molecular modeling. Apart from these, it is also used for designing detectors and analyzing their behavior. Finance, it is another area where the Monte Carlo technique has been used extensively. The technique is used for evaluating investments in projects and analyzing financial derivatives. In such cases, the probabilistic simulation models are used. Then telecommunication. How it is applicable in telecommunication? It is an area where the Monte Carlo technique is used to establish an effective wireless network and evaluate its performance. If the desired performance is not achieved, the network design is moving through the optimization process. Then games. Monte Carlo technique is used to design games related to artificial intelligence. Then we discuss about Monte Carlo simulation model. So there are 6 steps we follow to use the Monte Carlo simulation method. The first step, select the measures of effectiveness of the problem. Then step 2, identify the variables with a significant influence on the measures. And third one is to establish the probability distribution for each variable. Then the fourth one is to prepare the cumulative probability distribution for each variable. Then the step 5 is set random number intervals for each variable and generate random number. Step 6, finally, simulate the experiment by selecting random numbers from the table for the required number of simulating. Then we discuss about an example. So, as you know, Monte Carlo simulation methods, 6 steps are there. By using that 6 steps, we can solve an example here. In this example, a pizza seller records of previous month's sales in a tabular format. The data is given. The previous month means past data. Demand, number of pizza per day, the left hand side column, and right hand side column is number of days. So when the demand is 6, The number of days is 4. When number of days is 9, the demand is 7. The number of days is 6, the demand is 8. When the number of days equal to 8, the demand equal to 9. And the number of days equal to 3, the demand equal to 10. The demand is increased 6, 7, 8, 9, 10 in this way. The question asks you, simulates the demand for first 8 days of the month. The random numbers selected as 18, 45, 88, 10, 50, 57, 69, 06, 76, 74. Now we have to calculate. What do you want to calculate? Average demand. You have to calculate the average demand in the solution. So in the question, the demand, that is number of pizzas per day and number of days is mentioned in the question. Now from that question table, we can calculate the probability. What is the first step? The first step is identify the variable with a significant influence on the measures. That's why you have to find the probability. Number of days equal to 4 plus 9 plus 6 plus 8 plus 3, that is number of days equal to 30. Out of 30, what is the demand? Demand is 6 number of pizza. It means 6 number of pizza per day we will calculate it from the past data. Then you have to find the probability. The total number of days equal to 30. So 4 by 30, that is the probability, that is 0.13. Then 9 by 30, that is 0.30. 6 by 30, that is 0.20. 8 by 30, that is 0.27. 3 by 30, that is 0.10. If we add the probability, that is, the probability is always 1. So 0.13 plus 0.30 plus 0.20 plus 0.27 plus 0.10. The third column, if we add all the data, the probability becomes 1. Then we have to calculate the cumulative probability, CP. How we calculate the cumulative probability? From the initial point, that is 0.13, in the second, 0.13 plus 0.30. What is the cumulative probability? That is 0.43. 0.43 plus 20, that is 0.63. 0.63 plus 0.27, that is 0.90. And then 0.10, if we add, we get finally 1.00. So cumulative probability. Then random number interval. It is very important. That is the tag numbers, or we have to generate the random number interval. The cumulative basis or depends upon the cumulative probability, the random number intervals can be generated. That is 0.13. If you start initially from 00, then we end it 12, 00 up to 12. Similarly, 13 up to 42, 43 upon 62, 63 upon 89, 90 upon 99. So you have to generate the random number intervals. After generating the random number of intervals, in table 2, what is the question asked? The question asked, simulates the demand for first 8 days. Simulates the demand for first 8 days. And the random numbers already given. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8 numbers. So in this table, the number of days, 1, 2, 3, 4, 5, 6, 7, 8. Then random number, as per the question that I mentioned here, 18, 45, 88, 10, 50, 57, 69, 06. Then come here. So here, what do you write here? Random number interval. What do you calculate here? Random number. If it is 18, it is available in the interval, that is 13 up to 42. That means the demand is 7. In this way I am writing here demand equals 7. For 45, leave the question. 45, here the interval is 43 up to 62, that is 0.63. What is the demand? Demand is 8. Similarly, if we calculate the demand for 88 is 9, for 10 equals 6, for 50 equal to 8, for 57 equal to 8, 69 equal to 9, 060 is the 6. Now what is the total demand? If we add 7 plus 8 plus 9 plus 6 plus 8 plus 8 plus 9 plus 6, that becomes 61. So average demand equal to total demand divided by total days. What is the total demand? That is 61. 61 slash 8. So it becomes 7.625. So this is the example 1. Similarly, one more example we discuss here. A tourist car operator finds that during the past few months, in this past data, the car use has varied so much that the cost of maintaining the car varied considerably. During the past 200 days, the demand for the car fluctuated as below. Trips per week, and the frequency is mentioned in the question. That is trips per week when 0, for the frequency is 16. Trips per week when it becomes 1, the frequency is 24. Trips per week when it is mentioned as 2, the frequency is 30. In this way, for 3, that is 16. For 4, that is 40. For 5, that is 30. Using the random number is given in the question. Using random numbers, 82, 96, 18, 96, 20, 84, 56, 11, 52, 03, for a 10-week period, we have to calculate or simulate. We have to calculate or simulate the problem. Let us consider from table 1, trips per week. Second column, that is the frequency. Third column is the probability. Then the fourth column is cumulative probability and tag numbers. Tag numbers means the random numbers. So trips per week, that's 0. Frequency is 16. We get the cumulative probability 0.08. So the tag number becomes interval where the 0.08 is present. That is 00 up to 07. That is the interval. Upper limit and higher limit. Similarly, trips per week is 1. The cumulative probability becomes 0.20. So 0.230 means that is 08 hyphen 19. That means that is the interval. Then for trips per week 2, that is the frequency is 30, then 0.35 and 20 to 34. Because 08 to 19, that is the range is given. So 19 means we start from 20, that's why 20 to 34. 1 minus. Okay. Then we calculate the probability and cumulative probability and the tag numbers. Then from table 2, we have to calculate the total demand. Then it is very easy. So how can you calculate? So how many in the question it is mentioned as past 200 days. Trips per week is 0, 1, 2, 3, 4, 5, 6. Frequency is 16, 24, 30, 60, 40, 30. Total frequency is 200. Then probability. We have to calculate the probability. So total frequency is 200. So out of 200, the 16 is mentioned whenever the trips per week is 0. So 16 by 200 equal to 0 into 0.08. That is not into 0.08. Similarly, the probability when the frequency is 24 and trips per week is 1, that is 24 divided by 200, that is 0.12. When that is 30, the trips per week is 2, we have to find 30 slash 200 equal to 0.15. So in this way, we calculate the probability. After calculating the probability, we have to calculate the cumulative probability. What is cumulative probability? Add all the probability one by one in a sequence order. So what is the initial point? That is 0.08. If you add with 0.12, it becomes 0.20, then 0.35, then 0.65, then 0.85 up to 1.00. Then tag numbers or random numbers. We have to generate the interval of the random numbers. When the cumulative probability is 0.08, the interval is from 00 to 07. When the cumulative probability is 0.20, the interval is 8 to 19. In this way, we calculate all the tag numbers. Then, in the second table, the random numbers as per the week wise is mentioned here. Past week, the week number is 1 and the random number is 82. The demand, you can calculate the 82. How it is calculated? 82. Look the tag number 82. Means in the interval 65 to 84. So the demand is 4. I am mentioning here the demand is 4. For 96, look the slide. 96. 96 belongs to the same tag number, that is 85 up to 99. Then the demand and the demand we have to calculate. For 18, that is 1. For 96, that is 5. For 20, that is 2. For 84, that is 4. For 56, that is 3. For 11, that is 1. In this way, you have to calculate and find the total demand. What is total demand? If you add 4 plus 5 plus 1 plus 5 plus 2 plus 4 plus 3 plus 1 plus 3 plus 0, we calculate that is 28. Then, if the total demand is 28 cars, what is the average demand? Average demand equal to total demand divided by week. That is 28 by 10, that is 2.8. So 2.8 cars per week. Similarly, I am considering another example. Let us consider a manufacturing company keeps stock of a special product. Previous experiments indicates that daily demand as given below. In a tabular format, daily demand and probability. Here, directly the probability is mentioned, that is given. So daily demand is 5, the probability is 0.01. Daily demand is 10, the probability is 0.20. Daily demand is 15, the probability is 0.15. For daily demand 20, the probability is 0.50. For demand 25, the probability is 0.12. For 30, the probability is 0.02. Again, the question asks you simulate the demand for the next 10 days. Your daily demand is given. And the question asks you simulate the demand for the next 10 days. Also find the daily average demand for that product on the basis of simulated data. What are the simulated data? The simulated data is 89, 96, 18, then 96, then 20, then 84, then 56, then 11, then 52, then 3 for 10 days. Now we can solve by using the table 1. We have to calculate what is the actually Monte Carlo simulation. The Monte Carlo simulation said that select the measures of effectiveness of the problem, identify the variable with a significant influence on the measure, establish the probability distribution for each variable, prepare the cumulative probability distribution for each variable. So that's why you have to calculate the probability and cumulative probability. But the probability is given in some question, so we have to calculate the cumulative probability. That is 0.01. Then if you add 0.01 with 0.20, it becomes 0.21. Then 0.20 plus 0.15, that becomes 0.36. In this way, we have to calculate the cumulative probability. And then as per the random number, the random numbers are 82, 96, 18, 96, 20, 84, 56, 11, 52, 03. Then demand is as per the tag number 82. 82 belongs to, in this question, 82 from the tag number, it becomes 20. That is our tag interval is 36 to 85. In this way, we calculate for 96 that is 25, for 18 that is 10, for 96 that is 25, for 20 that is 10, for 84 that is 20, for 56 that is 20, for 11 that is 10, for 52 it becomes 20, for 03 it becomes 10. So we have to calculate the total demand, that is 170. Average demand equal to total demand divided by number of weeks, that is 170 divided by 10, that is 17 units per day. So in this way we calculate or simulate 3 examples on the basis of past data. Now I am summarized your today's class. In today's class, we know that what is actually simulation and where it is used. Then category of simulation, that means live simulation, virtual simulation, constructive simulations. Then what is the basic definitions? The actual simulation means a process of designing a model of a real system and conducting experiments with that system or with this model for the purpose of understanding the behavior for the operations of the system. That is known as a simulation. And what it is and what it is not. So simulation is a technique which uses computers. Simulation is an approach for reproducing the processes by which events of chance and change are created in a computer. And what it is not, simulation is an analytical technique which exerts solution, a programming language, but it could program into a set of commands which can form a language to facilitate the programming of simulation. Then reasons for using simulations, why we need that simulation. Then application area of simulation, how the simulation is used in the education sector, how the simulation is used in the medical sector, simulation in the entertainment sector, simulation in the manufacturing sector. Then types of simulations. On the basis of the changes produced in a system, this classification includes the following: static simulation and dynamic simulation. And on the basis of uncertainty in the processes, events, and controlling parameters of a system, the simulation is classified deterministic and probabilistic simulation. Then what are the steps to solve the simulation? That is identifying a problem, developing a model, collecting data, running the simulation model, interpreting the results. Then what is the importance and limitations of simulation? Then what is actually Monte Carlo simulation? How to generate the random numbers and the steps of the Monte Carlo techniques. So there are 6 steps. On the basis of 6 steps, we solve 3 examples. How to simulate. Example 1, and then example 2, and then example 3,